Good afternoon. My name is Sofiia Manko, and I'm a first-year student of Lviv Polytechnic National University. And I want to tell you about my project on topic cubic Lyre and cubics related to triangles. First, I want to say that in my research, the Cartesian coordinates are denoted u and v, and triangular coordinates by x, y, and z. A cubic in the Cartesian coordinate system is a locus of points whose coordinate satisfies the equality function of u and v is zero, whereas the function is a polynomial of the third order. Usually, curves of this type have the following form under the formula zero. An elliptic curve is one of the types of exceptional cubic curves, and the name of elliptic curves originates from elliptic integrals associated with finding the length of an ellipse arc. With the help of coordinates methods and the theory of system of linear equations, the existence of an elliptic curve of the form 5 that passes through the verticals of given triangle ABC has been proved. And in the figure 3, you can see the graphs of an elliptic curve passing through all verticals of a given triangle. Later, the algorithm was programmed, and you can see this program in the figure 4. Then the questions arose. Is it possible to independently formulate an algorithm for finding the equation of a cubic that can cross certain special points of an arbitrary given triangle? For this, I wanted to apply my previous research, which was related to Morley's theorems, and Morley's theorem itself can be formulated in such a way. The point of intersection of adjacent intersectors of an arbitrary triangle form an internal equatorial triangle. Using the method of coordinates, the coordinates of the verticals of Morley triangle DEF for an arbitrary triangle ABC were found. And you can see the formulas for this under the number 6. Then the algorithm was applied to the exceptional case of cubic and elliptic curve. Using the Kramer method, the coefficients ABC for the cubic curve equations of the form 5 were obtained by solving the system of linear equations under the number 7. And in the figure 7, you can see the graph of this elliptic curve. After this, since the problem was solved for the case of an elliptic curve, one of the cases of classical cubic of the form was considered. A system of similar equations was compiled, and the solution of which was adapted into a program written in the Python language. And in such a way was created a cubic Lyre, the new cubic, which can intersect one of the verticals of the given triangle ABC H00, as well as 3 verticals of its Morley triangle. And the graph of cubic Lyre is in the figure 8. This is a program for the cubic Lyre, and in the figure 9 it's enter data, then the results, and in the figure 11 this is a more detailed image of the intersection of the verticals of Morley triangle with a cubic Lyre. Also, I want to say about cubics related to triangles in the world-known classifications. For example, in the figure 12, it's a Thomson cubic. It's a cubic which can pass through the orthocenter and the center of the inscribed circle, the midpoints of the side of the triangle, and the midpoints of the heights. In the general classifications, it is designed as K002. And also you can see the equations in triangular coordinates. Then it is a Mackay cubic. It is a center of rotation of this cubic is the center of the described circle. The cubic passes through the orthocenter and the center of the inscribed circle. And in the general classifications, it is designed as K003. Triangular coordinates are the coordinates of a point which are specified using its relation to a triangle and describes the relative distance from all sides of a given triangle. And these coordinates can be used in computer graphics and different types of applications of cubics. To make my cubic more usable and to have an opportunity to compare them with widespread ones, I proved 2 theorems about transition from Cartesian to triangular coordinates, which can be followed with formulas under number 10, and from triangular to Cartesian coordinates with a formula under number 11. Then I also created programs for optimization of calculations of these theorems, and you can see this in the figure 16 and 17. And in the end, I also want to say about applications, because despite the fact that the properties of certain cores have already been studied in detail, this area of mathematics needs constant expansions and enrichments through its applications in physics, engineering, economy, computer graphics, cryptography, different graphics animations, and multi-level modeling, and also improving the operations of intelligent systems, namely their object recognition process, and the medical field, which deals with robotic surgery, biomechanics, and prosthetics. And as a conclusion, I want to say that theoretical matters on the properties and features of cubics and their possible use were developed. Also, a new elliptic curve is derived, which can pass through the verticals of an arbitrary triangle and later through the verticals of the first Morley triangle, as well as completely new cubic, the cubic Lyre. Its properties are described. Two theorems related to the transition between trilinear and Cartesian coordinates have been established. Programs written in Python have been added, which allow you to automate all calculations as well as to build the corresponding curves and their intersections with various points. And thank you for your attention.